This is our webinar on 5 transgressions that make your data pipelines cost too much. My name is Paul Lacey. I'm the head of product marketing at Ascend, and I'll be your host for today. And joining us as well, if you want to advance the slide, please, Shayaan, we have 2 amazing experts in the field of data pipelines and also cost savings in general. So we have Tom Weeks with us, our COO. He is a longtime startup veteran, knows a lot about how you save costs in multiple areas of startups, but in particular with data pipelines as well. And Tom has been managing the team here at Ascend for quite some time and working with customers to help them understand how they can get the best bang for their buck out of their data pipelines. So really privileged to have Tom with us. Welcome, Tom. And welcome also to Shayaan. Shayaan is our field data engineer, and Shayaan works with folks day in and day out on data pipeline optimization, management, things like that. So Shayaan has his hands in the gearbox of many different types of implementations of Ascend and data pipelines in general. And Shayaan has also been working in the data engineering world for quite some time. So a lot of information and insight into what you can do to make your pipelines perform better. And we're going to be getting into that here in just a moment. Before we jump into the content, just a couple of quick housekeeping items. This webinar will be recorded, and we will be distributing the recording after the session. So please feel free to enjoy the content without taking a bunch of frantic notes, because we will be sharing this with you for on-demand consumption. Also, please feel free to drop questions into the chat as we go through here. So one of the benefits of joining the session live is that you can ask questions of our experts, and we can actually answer those as we kind of go through the presentation. And we're going to be saving a little bit of time towards the end for Q&A as well. So please feel free to drop those questions in, and we'll get those answered as we go through here today. But without any further ado, I'll go ahead and pass it over to Tom, and Tom will walk us through a little bit of background on what we're going to talk about here today and what Ascend is. So Tom, please take it away.
Yeah, thanks, Paul. Thanks everybody for joining today. Paul gave me too much of an intro. The smart one here is Shayaan, and Shayaan will be walking you through the actual content. We'll get to that super quickly. For those who don't know much about Ascend, I'm just going to give you a really quick overview about the company, just in a couple slides, very fast, and we'll get over to Shayaan's content. So if you aren't familiar with Ascend, we are a data pipeline automation platform. We were founded quite some time ago. We're in our 8th year now of building out this wonderful platform with this incredible automation, some of which you will hear about, and backed by some of the top investors in the world. One thing I wanted to pop up here too, and you can find this on our website as well, if you were interested in digging in a bit more, there's a great analyst report published by GigaOM, and they have a analysis in this interesting target quadrant they put, if you're unfamiliar with it, on the right. And really the point here is to really look at the leading companies that are innovating and building platforms for data pipeline automation. And in that bottom right-hand corner is where you'll see the combination of platform plays and innovators, and quite a good group of people there, including Ascend as both as an outperformer and a leader in the data pipeline automation world. So next slide real quick. Great. We, as you'll find out, we live and breathe data pipelines. That's all we do. That's why we're a data pipeline automation platform. Just know tons about it over the course of the last 8 years, and customers all over the board, from startups to large global enterprise customers. Anybody who's got has data to manage, we are there to help. So with no further ado, let me flip this over to the smart one here, Shayaan.
Thank you, Tom. Might be overestimating my capabilities a little bit, but happy to talk through what I know. So yeah, today we're just going to be talking about the 5 transgressions that you hit that make your pipelines cost a little bit too much. We're also going to throw in 3 infractions there, just because 5 is a more even number. And usually I like to get the started with a little joke. One that I actually found myself on the internet, which is, data's like garbage. You better know what to do with it before you collect it, or you're going to pay. And this is by the famous author Mark Twain. I'm going to assume people are laughing, even though I can't hear or see any of you. So with that, we're going to go on to the first one, which is overpaying for your data ingest. So the very first transgression is obviously overpaying for your data ingest. The first step in any pipeline is going to be ingesting your data. But as many of us probably know, that's hardly ever the only step. You want to make sure that the bulk of your costs aren't coming from just replicating your data from whatever source you're reading from into your Snowflake warehouse, as this tends to leave little room for actual impactful work, like transforming the data to build out business critical use cases or delivering data to your end users. So more often than not, you're going to end up using an external tool to ingest your data. These tools are super great. They give you a lot of convenience. They handle a lot of the ingest for you, but they can ultimately inflate the cost of your pipelines. What we found is that they can end up costing 571 times more than the actual cost of compute. We measured this specifically with Snowflake compute, and we found that was 571 times the actual cost in terms of Snowflake credits. So what if we didn't have to have this cost, or we could eliminate the need for these costs? What if the ingest to Snowflake was, or whatever your data warehouse is, what if that was off very little charge or almost free? So you can allocate more of your resources towards actually building your business use cases, actually transforming and delivering your data. So what we found is that there is a way. One option is obviously building your own native ingestion. We do see patterns of people building their own native ingestion with Snowflake's tools, such as Snowpipe, and pulling the data directly into whatever warehouses they want to. While this is an approach that we see people use, we oftentimes don't necessarily recommend it because that introduces a lot of overhead for your team. So you have to build out and manage your own ingestion platforms. The other kind of option here is to use a tool that can ingest your data for free or very cheap, pretty much like Ascend, where we offer free ingestion, where the only cost you really pay would be for using for the actual Snowflake credits used to move the data. So we don't actually charge anything on top of that. And we found that customers who used a free ingest tool were projected to save at least 70K annually. So with that, we'll move into the next transgression that we often see when people are building out their data pipelines, which is not using Snowpark or Python for their workloads. This is more typical of when you're working with a pretty common warehouse like Snowflake, and you have the options for transformation such as SQL or Python. We'll get a little bit into the comparisons of how those two work and why it's usually better to maybe use Snowpark or Python for your transformations. But just as a quick overview, if you aren't familiar with Python or how it works, it's a very commonplace language within all of your data engineering stack. It's used for anything from data ingest to complex transformations to use cases like machine learning. We're in the world of like AI and big data, and all of that's going to be handled by Python more often than not. What we do tend to see is most data teams will end up using within their data pipeline some sort of external Python environment to carry out data processing that's separate from the rest of their data engine, the pipeline compute. So they're actually having to export their workloads to a different instance or a different environment. So in the following slides, we're going to be talking a little bit about how and where you should be using Snowpark, and also how to get the most out of it. So before we jump directly into Snowpark, let's pull back a little bit and compare the two most popular ETL transformation languages, which is SQL and Python. I'm assuming people have at least some understanding of both. What is SQL, what is Python? If you don't, SQL is a very simple declarative language that can be extremely powerful, and in querying your data, transforming your data, building out your data pipelines, but it is somewhat limited in what it can do. You are restricted to specific DML or DDL statements. You don't have a lot of external libraries or packages that you can use, but that also means that a lot of the work to optimize your actual processing isn't handled by your developers. So all they have to do is declare their business outcomes through SQL logic and let the query engine that they're running on top of handle all that optimization. With Python, on the other hand, it's also a pretty simple language. It's known for its readability and ease of use, but it allows for much more flexibility. Your transforms aren't necessarily bound to specific syntax or DDL or DDL statements. You can use, your transformations can be enriched by one of Python's numerous packages and libraries. And however, as we all know, when you have something like Python, which is extremely flexible, with more power comes more responsibility and ultimately more cost. That's why it's important to, when you're building out Python pipelines, it's important to understand what you're doing, why you're doing it. When we talk a little bit about Snowpark, and we'll talk about what it does, it kind of gives you a little bit of the best of both worlds here, because you are still writing your transformation logic in Python, and you have that ease of use with Python, but all that logic is still being pushed down to Snowflake's engine. So you also don't have to worry about the optimization as much. So let's talk a little bit about when and where you will be using Python or SQL for transformations. If we think about it, for most use cases, SQL is usually enough for any sort of data transformations, whether that's for data cleaning, enriching, aggregation, you mentioned it. However, you sometimes get to a point where you have more complex use cases that you want to be able to use Python for, since it is flexible and there's a wide range of libraries and packages you could be working with. So as this very sophisticated diagram represents, if you're not using SQL or Python, you may or may not need to reevaluate your life choices. This is not to take a dig at any Scala users. I'm just jealous that you actually know how to read Scala. I do not. So at the end of the day, it is a little bit like comparing apples and oranges. SQL and Python are pretty different tools. That's pretty obvious with, they have different use cases ultimately. So you might be asking what's the point of comparing both of them? Well, when we think about our transformations and our data pipelines as code, we have to think about the simplicity of use, the maintainability, and the reusability of our code logic and our transformations. And we often find that Python is actually the easier, more maintainable, more reusable route. So for example, we're going to be taking a look at just a simple transformation, both in SQL and in PySpark. So the syntax differences are pretty great. For SQL, you're used to your pretty simple SQL statements. In this case, it's a nested query. SQL tends to be what people are most familiar with, because if you're working in any sort of data space, that's the first kind of querying language you learn, which is super helpful. It is pretty readable. However, you get to the points where you have a bunch of nested queries and things can get kind of complicated. If you look at Snowpark, for example, if you're not immediately familiar with it, or you haven't used a similar type of language like maybe pandas or I would say PySpark that have a similar format, it could be a little bit difficult to read at first. But what we find is that once you're a little bit more familiar with Snowpark, it becomes actually a lot easier to trace the code logic and understand what it's doing, which makes your code much more readable. For example, in this case, I can trace exactly what my code is doing. It's taking this input df data frame, it's grouping it by the specific weather date timestamp, and then it's creating a new column for that. And then it's carrying out that aggregate off of that group by getting the max precipitation value. Apart from reusability, when we think about our code, we also want to think about maintainability. We also want to think about maintainability and reusability. So for example, we want to be able to create logic in our code that's reusable across our pipelines. This is totally possible to do in SQL, however, that does mean you have to ultimately templatize your SQL. For example, if I want to reuse the SQL code, I would just have to template out the table names, the columns that I want to get the max values off of. I would have to make sure that anytime that I was calling this, I would have to validate any inputs, because SQL injection is a thing. I would have to make sure that the value being passed in are correct. I would also have to make sure that my SQL syntax is correct, and I'm not going to know that until I actually send the SQL to Snowflake using their SDK. So with Snowpark, it makes it a lot easier because I know I don't really have to worry about the syntax as much, and all I have to do is bring this logic out into a specific function, pass that function the data frame that I want to use, and I can reuse that code as much as I want to. So Snowpark, as I mentioned, very powerful tool. However, we sometimes find there are some challenges that people run into when using Snowpark. So it's important to set your teams up with success and build the right development framework when you're working with Snowpark. Obviously, as developers, what we want to do is be able to open up an IDE and just start coding. But there's always that initial setup of making sure your development environment is all set up, your creds are accessible, you have the right steps set up to set up the client, you have ingested all your data that you need to start working on it. So it can be a bit of a tedious process, and onboarding new developers or starting off with new use cases there's some friction involved there. Another common problem we sometimes see is that, when you are making changes within your data pipelines, within your code, you have to manage the downstream propagation of these changes. So like if the change that you created has some schema implications downstream, you have to make sure that your downstream transformations their schema is actually updated as well. So that introduces more changes that you have to make and more points of failure when you're deploying new pipelines. Another common problem is having multiple types of transformations within a single pipeline. A lot of tools won't actually let you have a multi-mode data pipeline where you can ingest using Python, then do a transformation, then SQL, then maybe run some analysis with Python, toward to a SQL transfer again. You usually have to switch between a bunch of tools or different pipelines even. So if you want to make a change to what should be a single pipeline, you would end up making changes to multiple. And then finally, it's simple that change control and DDL management between your environments is hard, whether you have separate prod, staging, or development environments, or even different pipelines hosted in different environments. It's difficult to manage the schema and the DDL between all of those. So there are some friction points, and it's important to understand how best to set your teams up for success when you're working with, building your data pipelines with Snowflake. So it's really important to use a tool that takes care of all of that bootstrapping for you, so that your developers can just jump in and start building their business use cases right away. We are living in a world of AI and productivity with AI. So it's a lot of making sure that you're not spending time doing things that can already be automated. You should be focusing on the things that actually bring value and bring business, and let someone who's really good at doing all that tedious work handle it for you. So for a system like Ascend, we do all that bootstrapping for you. We import all the packages that you need. We get you ready with all the data that you need. What you're seeing right now is a simple transformation template that we provide that really we give you everything, your Snowflake session, the inputted data that you need, as well as importing all the packages that you need from Snowpark. So you can literally just jump in and start writing code. So with that, we understand that Snowpark is a very powerful tool, but when it's used in partnership with the right platform like Ascend that can help boost your productivity, you can unlock a lot of cost savings as you're saving a lot of time and effort while creating stronger data pipelines that are easier to maintain. So we estimated that teams that use Ascend to integrate Snowpark into their pipelines can save up to 5% annually. I'll take a little bit of a breather there. We got two transgressions, got 3 more to go. The third transgression there is not using partitioning. Every data tool has its own constructs on what partitioning looks like. So it's important to understand the mechanisms of partitioning in whatever tool that you're using, because this helps you best optimize your compute. So what is partitioning? Well, I like to start off with another joke, which is, how do you eat an elephant? One bite at a time. That is actually a very good joke, and I'm going to give the credit for that to Paul. So what is data partitioning? It's essentially logically splitting up your data into smaller chunks so you can isolate the compute for the individual chunks. Anyone familiar with any older big data paradigms like Hadoop or Hive would be familiar with these practices, but data partitioning is now as relevant as ever, as we're also looking for ways to best optimize compute and introduce cost savings. Partitioning allows for better performance because now you're running your compute on smaller sets of data, so they can run a lot faster. It also allows for more scalability because since your data pipelines since your data is split up into smaller pieces, these can be split over whatever compute you're using, whether that's various nodes or different warehouses, however your engine is doing compute. It just makes it easier because now you can scale horizontally instead of having to scale vertically, which is very expensive. So, and finally, it makes it super easy to figure out any data quality issues or error handling, because you can understand when, instead of having to look through your entire data set or having your entire data set fail, you could have specific data quality checks on specific partitions so that you can isolate which partitions are having issues with data, and you only have to look at those partitions of data. So we take a little bit of a look at the common dimensions that a lot of our customers partition off of. And one of the most common ones that we see is time-based partitioning. This usually means that the data has some sort of time series data, whether it's log data that's coming in every so often, or it's even some sort of fact table, but there are changes being made over time, and those are being maintained historically within the table. We usually tend to see more time-based incremental data. With this sort of incremental data, it usually makes sense to batch data into partitions based on whatever granularity makes sense. So for example, minute partitions or hourly partitions for higher frequency data, or daily, weekly, monthly partitions for longer running batch style data, maybe data that doesn't come in so often. But the important part of that is maintaining the incrementality means that your data pipelines can be built to only process new or updated partitions of data, which greatly reduces costs as you don't have to process the entire data set when new data comes in. You can also partition by other common business objects, such as customers, accounts, products, regions, and it does ultimately depend on your use cases and what you plan to do with your data. So when we think about partitioning and why it truly matters within our data pipelines, we can understand it in terms of what one asset of that, which is when we want to make changes to code. For example, you want to make a change to your pipeline. The pipeline that change, however, only affects a specific partition of data. You don't want that to have to reprocess your entire data pipelines. You want it to only reprocess the partitions that it absolutely needs to reprocess. This is where it's really important. We'll talk about this in a little bit, why partitioning is important. It's also important to have a data-aware control plane that is managing the relationship between these partitions. So with partitioning, the overall bottom line there is that working with our customers and seeing them implement incremental processing with partitioning does help to reduce costs, which can be combated by having intelligent control planes that run your data pipelines. they effectively reduce cost of transformation changes in product pipelines. And we've estimated based on the patterns from our customers that it's about a 40% to 60% projected annual savings when they move their pipelines to more incremental approaches. All right. Oops. Sorry, I skipped ahead there a little bit. Got a quick teaser. There we go. So the fourth transgression is rerunning your entire pipeline all the time from start to finish. Now, you may be wondering why that might necessarily be a problem, because don't we want our pipelines to start at ingest, go through its transformations, and then deliver the data? Well, in most cases, yes. But how do we want our pipelines? The real question is, how do we want our pipelines to react when something breaks in the middle of our pipelines? Or how do we want our pipelines to react when we make changes to it? Oh. There we go. So one thing that's certain is that pipelines will always fail, no matter how much QA testing we do, or how much, how many tests we write, or how much QA we do. We're always going to experience unknown issues that creep up on us and alert us at 2 a.m. when our pipeline fails and our data hasn't been delivered. So we missed our SLA. We actually found that a study by Excel data sees that about 45% of data leaders experience pipeline failures 11 to 25 times in the last 2 years. In the case of these pipeline failures, it is, it's important to respond and fix your issues, but it's more important to respond quickly, because you want to be able to meet those SLAs. You want to make sure that a hiccup in your pipeline hasn't railroaded the rest of your pipelines downstream. You want to be able to resolve these issues quickly. Not only that, you want pipelines that are smart enough to understand context and know when they need to retry, so that you don't have to have your L1 level of support engineers jump in every time there's an error. Your pipeline should be smart enough to understand what the context of the errors, which ones are ephemeral, and when to retry on them automatically. So when you have some sort of checkpointing, or when you have a way to recover or have context-aware pipelines, it actually helps to respond much faster to these failures, because then you can restart from the point of failure. What does that necessarily look like? Well, let's say your pipeline does fail in the middle of the night at one transformation along the way, and you get an alert that, oh, there was a hard failure. All you should be able to do is go in, find the failure, fix it, and then restart from that point going forward. You shouldn't have to restart the entire pipeline from the beginning. Another part of this, which is the retriability that I talked about, is that when your pipeline does face an error, your data pipeline should have the context to understand, oh, I can maybe retry on this a couple of times to see, hey, maybe this pipeline error will go away. If not, then I'll go into a hard failure mode where I need someone to jump in. Like I said, when you have a smart control plane that can understand the context of a pipeline, you just need to restart from the point of failure and data can flow through. So if we talk a little bit about how that's even possible, or what does it take for your pipeline to be smart enough or aware enough to actually be able to retry, what we're talking necessarily about is understanding the context. Your whatever control plane understands context, as well as there's checkpointing along the way, so you can pick up from where you left off. When you don't have some sort of data-aware orchestrator or scheduler or control plane, whatever you like to call it, your data pipelines tend to act like an automatic lawnmower, where it's doing a great job while it's running, mowing half your lawn. Then it stops, it breaks. You have to go in and fix it, or it gets stuck on some weed or something, and you have to go restart it. It then doesn't realize what it's already done and starts mowing your entire lawn from the beginning. While you don't have an SLA on lawn mowing, you do have SLAs on your data. So you don't actually want to have to rerun entire pipelines from the start. You want your data aware control plane to be able to understand, hey, where have I been? Where do I need to go? What have I already done? What are the next steps that I need to complete? You want to be able to recover from any sort of changes or errors fast and intelligently. This becomes really important when your data pipelines look a little bit like this, where they get a little bit more complex and there are a lot of interweaving steps. It's important for you as the user to only have to worry about the code logic. You shouldn't have to worry about all the dependencies from one point A to point B, so that when something changes or when there's an error, you have to go in yourself and understand what the impact to the error is. You should let your control plane take care of that for you. All you have to do is fix the logical error that occurred. So to recap, when you have restartability in your data pipelines with checkpointing of data and automatic retries, your pipelines will recover from failures about 10 times faster, and you could see annual savings of about 10%. All right, so we did make it to the very last transgression. The final transgression that we're going to be talking about is using the same size warehouse for every workload. This is specifically talking about Snowflake, but it is important to understand that a lot of the tools that we use nowadays give you the ability to scale your warehouses up and down. And we're going to be talking a little bit about why that's so important. So specific to Snowflake, before you had Snowflake with the ability to scale your data up and scale your resources up and down without worrying about storage, your compute and storage were very tightly coupled. This was usually built out on cluster architectures that allowed for a lot of parallel processing, which was definitely swift and low cost. But over time, there were certain frustrations that developed because scaling any sort of resources was time consuming. You usually had to get in touch with an infrastructure person to do that. You had to incur some disruption for the scaling to occur, and you had to scale up your actual servers, and so you had to scale up both your storage and your compute. With Snowflake, the separation of compute and storage, you now have the option to scale and tune your compute without having to fret about the storage of your data, because tools like Snowflake will handle that logical integration between your storage and your compute. So now that's a lot easier to be able to scale your compute up and down. It makes it super easy to start scaling your workloads. You're sizing your compute to the size of your workloads. You can do this. Tools like Snowflake make it super simple to tune and maximize efficiency and speed while reducing costs without having to incur any sort of disruption, or anyone who knows SQL can go ahead and change the size of their warehouse. So it's become much simpler in the last couple of years. So now that you can scale up and down, it's really important to think about, for my size workload that I'm running, what is the best warehouse size for that? And at Ascend, with our customers, we tend to see a couple of different types of warehouse usage workloads and their associated warehouse usage. So for example, for really large batch jobs, maybe your daily batch job, a weekly job, a monthly job, we tend to suggest scaling higher, so somewhere in the XL family. The reason for that is obviously if you were to assign a smaller warehouse to this, you would end up queuing your warehouse for a very long time, and the processing could take much longer than it needs to, and you could end up missing SLAs. You also don't want to be running smaller workloads on a larger warehouse because you're wasting money, because you could be running those in smaller warehouses, and you're also stopping the larger jobs that need that warehouse from running. So for those specific high frequency, low latency jobs, things running every couple of hours, every hour, every minute even, we tend, smaller to medium-sized warehouses, just because these warehouses are going to be up for longer periods of time, so there's less of a cost implication. As well as, you don't want to like I mentioned, you don't want to run small jobs on big warehouses because that's just wasting money. And you don't want to run big jobs on smaller warehouses because it's going to take forever and just clog up that entire warehouse. So tuning your warehouses isn't a one-size-fits-all. It's not a problem you solve immediately. It is an iterative process, and you definitely learn as you go. The trend we tend to see most of all is, starting small and then going bigger as needed. With a tool like Snowflake, as I mentioned, super simple to scale up your warehouses. And you also need a tool that helps you understand your warehouse usage. So, Snowflake will give you the ability to see, per warehouse, hey, what is the actual utilization percentage of my warehouse versus how much time were things spent in queue. If there was low utilization, I know I need to scale down. If there's high utilization but a lot of time queuing, I probably need to scale up my warehouse. But that's kind of all you get. So it's important to have another tool that lets you understand, per job or per workload, what is the actual utilization there. So it's important to have an observability tool like Ascend that lets you see, hey, based on this specific pipeline that's running, what is my usage there based on this workload, based on this warehouse. So you can tune and optimize from there. You can see how much compute a specific pipeline or a specific component or a specific transformation is using. And you can go and optimize and tune there, or understand that, hey, I need to scale up my warehouse for the specific one. So overall, when you think about the exercise of sizing your compute, the best practices we tend to see are choosing an orchestration tool that makes it easy to assign and use warehouses, run testing on performance, and continue to iterate on sizing. Like I said, not one size fits all. It is an iterative process. Your data will change, your data will grow, your data will shrink. It happens all the time. But if you have an observability tool that lets you see where your consumption is the highest and optimize from there, we find that tuning your warehouse usage could create an annual saving of about 15%. All right. So we did make it through all the transgressions. All I have left is 3 infractions for you all. So let's get through these. Like I mentioned, feel free to throw in any questions within the Q&A panel as we go along, and we'll be addressing those right after the last 3 infractions. So the first infraction that we see is doing your development on production size data sets. This is a pretty obvious one, but we do see this happen a lot where people will do development on their production data and ultimately do development on production size data. Having a CI/CD process, obviously, within your data pipelines is super fundamental, super important, helps you speed up development, allows for change tracking, and lets you test pipelines before you deploy them to production. However, you have to be cognizant of what data you're actually running your development pipelines off of, because oftentimes your development pipelines are you're going to be running them a lot more within shorter periods of time. So you don't want to have to keep running things on top of production size data. So the general best practice that we see there is, one of them is the ability to create zero copy clones. This is something that's specific to Snowflake, I believe, but I think other tools might have the ability to do this. But when you create a zero copy clone, essentially what you're doing is creating a reference to your production data that you can query off of and you can do development off of. This doesn't create an actual, physical in-memory or on-disk copy of the data. It's a reference, so there's not any added cost in terms of storage. And you can also make the copy a subset of the data within production. So you can actually run queries or run development off of a small subset of the production data so that you're not, inflating your compute costs just by doing development. And then Snowflake also guarantees that any changes made to the clone are not actually implemented on the actual production data set. So you don't have to worry about making accidental changes to production data. Another great development practice is developing locally where you can. Like I said, Ascend gives you the ability to bootstrap super fast when it comes to doing development. We have a ton of SDKs and tooling that people use to develop locally. It's really important because it makes your teams a lot faster, it makes them more agile. People are usually more comfortable within their local development environments, so they help them speed up the development process. And then, as I mentioned, CI/CD to manage your pipelines, also very important, as when you have a proper CI/CD process built in place, that includes version control and being able to quickly and easily roll back your pipelines. You can deploy changes faster, recover from failures faster, roll back faster. And finally, with unit and integration testing, that's always going to be kind of number one in terms of before deploying your pipelines. You want to make sure that all your transformations work as you expected with the set input and the right output. But you also want to make sure that your pipelines run start to finish, they meet all their integration testing. So a common pattern there is that in development, you're running unit testing on each of your transformations as you make changes. But then when you push those to, let's say, like a staging environment, you can run integration testing on the entire pipeline start to finish. So the next infraction is duplicating data sets because of lack of reuse. What this means is oftentimes when you're working in large data teams, you're not completely aware of what data products other people on your team are making. So there could be a version of the data that was created by a team member that you also need. But unless you're willing to scroll through your entire Snowflake database or Snowflake schema or post on a Slack channel asking, hey, has somebody made this very specific data set that I need? You're not going to be aware of those data products anywhere else. That does ultimately lead to a lot of duplication of work, duplication of data, so time wasted, compute wasted, resources wasted. It's really essential to have a catalog of your data products that makes it easy to see, hey, what data sets do I have available to me in a simple, easy place, human readable names. So I can see, hey, what data sets do I have available? Oh, okay, I have this. I can easily subscribe to this data set and use it in my development flow. Within Ascend, we have a concept of data shares, which helps you do that, which means any data transformation that you've built, you can create a data share off of that. And then that data share can be subscribed to by anyone else. It is kind of like a publisher-subscriber model, where you publish the data set that you created, and then any number of people throughout your Ascend environment can subscribe to this data and just start building transformations off of it. Any changes made in the upstream data is automatically carried down to the downstream data as well. So you can guarantee that the data you're working off of is always fresh. You're always working off the correct version of data. And finally, we're going to be jumping into the final infraction, which is not being aware of where things are running. What this means is when you're using an external tool for building or maintaining your data pipelines, these tools are very useful, very convenient, help you speed up your development a lot. But it's really important to understand what is running and where, so you can be assured that your data is safe and that you're not paying for things that you don't need. We often see this with, some sort of tool that says that is controlling your pipelines and claims that they are push down services. So all your queries and transformations are being pushed down to Snowflake. Sometimes that's not the case, especially if they're running Python workloads. That usually means that they have to spin up an external service, maybe in a different cloud account that's separate from what you're running Snowflake in, and export the data there, run the processing there, ingest the resulting data into Snowflake. So it's just really important to be cognizant of what and where your data is going. Most tools, if not all of them, are super transparent about it because they also want your data to be safe, but it's also always important to ask the right questions or make sure that the tool you're using is super well documented in exactly how they run your pipelines, so you can be assured that, hey, I know where my data is going, I know exactly where it's running. And with that, we made it through our 5 transgressions and 3 infractions that make your data pipelines cost too much. Just to review, it's overpaying for ingest, not using Snowpark for Python, not using partitioning, rerunning the whole pipeline all the time, and using the same size warehouse for every workload. With these, hopefully this gives you some useful, helpful tips that help you understand, hey, where your costs are going and maybe how you can best optimize these costs. But if you have any more questions, I'm happy to answer them now. Or feel free to visit ascend.io to schedule a demo with us, talk to an expert on the team that can help to see how Ascend can help you reach your data pipeline goals.
Thank you, Shayaan. That was amazing. And I think we just heard a bunch of people clicking screenshots on that last slide that you just had up. Yeah, which is awesome. No, I jest, but yeah, this is great. This is an amazing overview of all the different ways that you can potentially save money and potentially be overspending on your data pipeline. So thanks for taking the time to run us through that and collecting all the research and everything. This is wonderful. We did have a few questions that came in, Shayaan, during your talk, so
Sure.
we can go ahead and work our way through those right now. So, and this one is pretty new, so it just came in. It said if you add up all the savings, it totals to almost 100%. Does this mean the pipelines will run for free with all of these optimizations, right? So what do you think?
The short answer is I wish. And I wish that for everyone, that you could run data pipelines for free. Unfortunately, that is not the case. Yeah, the numbers, if you add them up, be 100, but they're all the specific transgressions that we mentioned are specific to specific use cases or types of pipelines that you're running. So it's all of those cost savings are going to apply to every pipeline that you're running. Some of them will apply to some of them. So it's not necessarily that, hey, I can drop 100% of my costs for a single pipeline. It's depending on what that pipeline's doing and how it relates to each of these transgressions. That's how how you can think about those savings there. Hopefully that answered that.
we didn't invent a 0-point energy device, Shayaan, to give people data for free. Yeah, that's too bad.
I mean, you could just not pay your cloud bills. I mean, they'll come after you, but it'll be free for a little bit.
Yeah, I don't know that we would recommend that strategy as a long-term strategy to success. but definitely, if you're only thinking short-term, maybe you could pull that off. You just have to move quite frequently between your different cloud providers. Yeah, no, great. Thanks for that. Yeah, and another question kind of in the same vein, I guess, Shayaan. So someone was asking, are there particular workloads that you would suggest for Snowpark versus SQL? I know we spent a lot of time on that earlier, looking at the differences between them. Is there any kind of like a boundary condition that you'd say, hey, this type of thing is better for this type of a language?
Yeah, I think when you start to think about what your transformations are doing, so let's say you want very specific custom behavior. For example, you want to run UDFs that are maybe taking your data, pushing them to an API that API is an endpoint for a machine learning algorithm that's doing some analysis on the data, and you want the result to come back and enrich your data. You can't really do that in SQL. So with something like Snowpark or Python, you can define these user-defined functions, UDFs, that give you a lot more custom control on the types of transformations that you're running and what you want to do. Like I mentioned, it's ultimately, what is it that you want to do with your pipelines? The tools aren't necessarily important. It's the outcomes that you're aiming for and how you get to those outcomes. So if you can run something in SQL and you have a SQL team, it probably doesn't make sense to make your entire team learn Python just so that you can start using Snowpark if you can achieve the same thing in SQL. Same thing with Python. If you have Python developers on your team, use the tool that's best equipped for your team. Like I said, it's really not about the tool. It's more about the outcomes that you're trying to achieve and what are the limitations of each tool.
Got it. Yeah, makes total sense. Yeah. So I guess the answer is, a very qualified, it depends. But
Pretty much.
definitely, yeah. The UDF capability set is quite interesting, right? Where you're able to, store these procedures and then reuse them and call them up from time to time. And I imagine as people are getting into more data science, machine learning type workloads, that could become very powerful over time, right? As they start to build up those libraries.
Yeah, it really is like when you get into the more complex data transformations of, something beyond just a simple SQL query. That's usually where Python gets in. So it's more of a tiered approach. It's like, hey, can I do this in SQL? No, probably need to do this in Python. And like I mentioned with Python, you just have to be careful about what you're doing because, you don't want to be running a single threaded for loop across 50 million records. So like I mentioned, you have to think a little bit more about what you're doing, how to best optimize, how to make things run faster.
Perfect. Yeah, thanks for that, Shayaan. Great insights. Another one that came in, I think, while we were talking about the transgression, or no, it was the infraction, not the transgression, but the infraction of doing your development on production size data. Somebody was asking, are there any particular downsampling strategies that you've seen? Is this similar to the partitioning of data? I guess what they mean is like, would you downsample by partitioning the data potentially? I guess what do you kind of see as like a best practice there?
Yeah, for that one, you want to make sure that you're getting a fair sample of your data. So when you're creating these data clones, usually what I usually recommend is like, let's say you have time partition data. You probably want to do development off of data that, historical data that you've already processed, so you understand what the outcome should be, so that when it comes to writing tests or you're developing, you know what to expect. Another option is really try to choose random data points from your production data sets. So you're at least getting somewhat of a guarantee that you're getting the full range of the typical data that you wanted to develop off of. It's not going to be 100% perfect because there are cases where there are certain nuances in your production data that you might miss when doing development. That's actually what I would suggest staging pipelines should be for. Staging pipelines should actually, I think, be off of either production data or 70 to 90% of your production data, because you want that staging pipeline is not going to be running every time you make a change. It's going to be running much less frequently, but it lets you see how your pipeline is running, if there are any actual issues with the larger data sets before any of those changes impact production. So I think having that middle step of staging, where once you're okay with the change you've made in development, push up to staging to see how it performs with the entire data set. I think that's super helpful with data pipelines and makes your production pipelines more resilient and helps you catch issues a lot faster.
Yeah, well said. And I guess, underneath that is the assumption that folks have some sort of CI/CD type capability set built into their data pipelines, right? So they have the ability to treat pipelines as code, or at least migrate pipelines between various environments and things like that in order to support that kind of a promotion strategy.
Yeah, for sure. You will definitely need something that is managing those the movement of your pipelines from one point to another. Having your pipelines as code is very, very helpful. Just because it makes change tracking, understanding what changed a lot easier, as well as logs and metadata about your data that you've collected and can report on. Really helps you to understand and profile your data, help see the differences between dev, staging, and prod, so you can better expect, okay, these are the kind of things I expect to catch in development. These are the things I expect to catch in staging, and none of that, I shouldn't be catching anything in prod, but everyone gets those 2 a.m. pages. It happens.
It's the real world, right? Yeah, exactly. No, that's awesome, Shayaan. Appreciate that. And just a reminder for folks that are on the phone with us, we got a little bit more time. We're coming towards the end of our questions here. So if you have any other questions you'd like to ask, go ahead and pop those in now for Shayaan, and we can spend as much time as we need to kind of get through all this stuff. But one other question, Shayaan, is the last one we have in the queue for right now. It says, how does Ascend optimize? Does Ascend automatically learn over time, which is the most cost-effective and efficient way to run a query?
Yeah, so Ascend actually isn't what manages the execution of your query. We are a push-down platform where we are pushing down your data to your specific data plane, which is what we like to call them, Snowflake, BigQuery, Databricks. So the actual execution of the compute logic is handled by these engines that are, developers have been working over them. Really talented developers work on them for years to best optimize it. We are the orchestration tool. So we handle what we're really good at is understanding the dependencies between your transformations, between your pipelines, and understanding, hey, when do I run this specific query? When do I run this specific component? So you don't have to worry about, the dependencies between your pipelines. So while we're not necessarily optimizing your queries, we do offer a lot of tools for that. Like I mentioned, Ascend has its own concept of partitioning your data. So you can actually control what partitions of data, how the granularity of partitioning your data, or how big of a partition to send down to Snowflake, Databricks, BigQuery, etc. But yeah, short answer there is we don't specifically optimize your queries themselves. Those are handled by the underlying data planes.
Great. Yeah, great answer. And definitely, the sort of things I think that Ascend does optimize are things like, as you mentioned, Shayaan, the partitioning strategy in aggregate, right? And we're talking specifically partitioning strategies for data pipelines. So Snowflake handles, and many of these other data platforms handle the partitioning strategies of the data that's stored in their tables. So their tables perform extremely well. And what we're thinking about from an Ascend perspective is how do we partition the data sets as they're flowing through the pipeline so that we can say, hey, there's a couple different tables here that are all different partitions of the data set, so that when we run data pipelines, we don't have to rerun the processing over huge tables. We can kind of break it out in that way. And thinking about things like how do we checkpoint the code or checkpoint the data as we go through these pipeline runs and things like that. So if things fail, we restart from the last good checkpoint as opposed to restarting from the beginning and that sort of stuff, right?
Yeah, our bread and butter really is that orchestration step. We manage the interdependencies of individual partitions themselves, not just like transformations as a whole. So you understand the flow of your data from partition to partition within Ascend. And that really helps with, only running the things that need to be run, making changes only where they need to be made. That the smarts of that orchestration is what we handle for you.
Absolutely. Wonderful. All right. Well, it looks like that's all of the questions that we have today, Shayaan. So I guess the last form of savings is time savings, when you get a little bit of time back in your day in between meetings, and who can complain about that as well. So I guess that's the savings that we'll leave all of you with here on this webinar. But we really appreciate everybody tuning in and some great questions coming in from the audience today. And also really appreciate your time, Shayaan, and kind of walking us through all that information, putting that all together for us as well.
Awesome. Thank you so much, Paul, for organizing all of those too, and helping me with Q&A too.
Absolutely. Yeah, my pleasure. Well, thanks, everybody. This has been our webinar on the 5 transgressions that make your data pipelines cost too much. You can go ahead and learn more about this at ascend.io, and we'd be happy to have a conversation with you about how you can apply this in your particular instance. If you've got data pipelines that you feel are costing too much, we can spend a little bit of time with you to understand where that might be coming from and how we can help. So please feel free to reach out, and otherwise have a great rest of your day.
Awesome.
Cheers, everybody.
Thank you, everybody. See you around.